guys, I'm Sophia. I am Serena. I am Lian. I am Riza.
And I'm Ivan.
Welcome to our vlog. Come and join us as we show you the beauty of math in our nature. Let's do our vlog. Let's go. Today, we are going to explore the beautiful world of math in nature.
Yes, you might not think about math when you look at a sunflower or a seashell. But guess what? Math is literally everywhere in nature, especially in the patterns that shape the world around us.
Math plays a key role in how nature organizes itself.
And today, we're focusing on two interesting mathematical patterns, the Fibonacci sequence and the golden ratio. According to research, the Fibonacci sequence, named after Leonardo of Pisa, also known as Fibonacci, is a series of numbers where each term is the sum of the two preceding ones, starting with 0 and 1. Although Fibonacci introduced the sequence to the Western world in his 1202 book Liber Abaci through a problem about rapid population growth, it had already been studied in ancient mathematics as early as 200 BCE, particularly in works by scholars like Pingala and Virahanka. The golden ratio is denoted as phi and approximated to be about 1.618. This irrational number has been tied to aesthetics, nature, and art since ancient times. Two quantities are said to be in the golden ratio, if the ratio is equal to the ratio of their sum to the larger quantity. This concept was investigated by ancient Greeks such as Euclid in Elements. A significant connection exists between the Fibonacci sequence and the golden ratio. As the Fibonacci number increases, the ratio of consecutive terms approaches phi. This is why both the sequence and the ratio appear in natural patterns, such as spirals in shells and galaxies. Together, they have inspired centuries of explorations in mathematics, science, art, and architecture. And now, come with us as we show you what is mathematics in nature. Let's go!
Look around and you'll spot math everywhere. Nature loves patterns. Plants, flowers, and even trees, they follow certain rules that can actually explain through the use of math. Let's start with the Fibonacci sequence. This is a sequence of numbers where each one is the sum of the two before it. It goes like 0, 1, 1, 2, 3, 5, 8, 21, and so on. Let me show you an example of it.
As the sequence continues, each number is bigger, and the relationship between consecutive numbers becomes more interesting. But what does that have to do with nature?
And now, the Fibonacci sequence in nature.
Let's have a few examples. You've probably heard people talking about how sunflower seeds are arranged in the seed head in a spiral. And if you actually take count of the spiral that you see, most often, these numbers are Fibonacci numbers 34 or 55, for example.
Or think of a spiral of a pine cone. If you take a closer look, the layers of the scales are also following the Fibonacci sequence. Plants also apply the Fibonacci sequence for their leaves, petals, and seeds to make the maximum space and light absorption which would help them grow best. So plants don't just grow randomly. They grow in a way that optimizes their chance of survival, and math helps them do that.
You may discover something unique if you examine the Cattol structure more closely. In fact, it adheres to a pattern known as the Fibonacci sequence, which is widely recognized both mathematics and nature. Each number in this sequence is equal to the sum of two numbers. However, what does the Katol have connection to this? Indeed, if you examine the Katol spiral pattern, you will notice that it resembles the so-called Fibonacci spiral, drawing quarter circle with radii that adhere to the Fibonacci sequence produces this spiral. Although the spiral shape of the Katol may not precisely correspond to each Fibonacci number, it is nevertheless influenced by the organic pattern. Not only does this pattern appear in Katols, but it is also found in flowers, shells, and even the formation of galaxies. The spiral form facilitates balance and effective growth and expansion. The spiral in the Katol helps it to burn uniformly and discharge mode gradually, deterring insect for a longer amount of time. Thus, keep in mind that a Katol is more than simply a basic coil the next time you see one. It serves as illustration of how mathematical patterns found in nature may appear in commonplace items, even something as basic as an insect repellent.
Next up, the golden ratio. This special number, 1.618 and so on, show up in art, architecture, and even nature. And it's super connected to the Fibonacci sequence.
Take seashells, for example, like the Nautilus shell. Its spirals follow the golden ratio perfectly.
And it's not just shells. You can spot the golden ratio in the spirals of galaxies, hurricanes, and even in how certain plants grow.
In addition, the Fibonacci sequence is a mathematical pattern that often appearing in nature, including in galaxy. In spiral galaxy, the alignment of stars, gas, and dust may form a spiral pattern that roughly follow the logarithmic spiral, closely related to the Fibonacci sequence.
Want to hear something wild? The spiral ear is also based on the golden ratio. Crazy, right? Let me show you.
The Fibonacci sequence and the golden ratio show up in surprising ways in our everyday lives, from the way plants grow and seashells form to the designs of buildings and artwork. These patterns create a natural sense of balance and beauty. They're not just about looks either, they help us solve practical problems in areas like technology and science. Understanding these patterns help us see the connections between math, nature, and human creativity, making life's design feel both meaningful and inspiring.
In addition, if the Fibonacci sequence and the golden ratio didn't exist, the world would look and work very differently in many ways. These two patterns are found all around us, in nature, art, architecture, and even in how things grow. They help create shapes, structure, and proportions that are common in the world we see every day. Without them, many things might not appear the same, and the way things grow or develop could change.
First of all, we have nature's growth. The Fibonacci sequence is used to describe the growth of plants, flowers, and even creatures. Without it, flowers might not have as many petals or leaves might not grow in the same spiral manner. This may alter the growth and development of plants and animals. Second, we have beauty and design. Because it produces aesthetically beautiful shapes and proportions, the golden ratio is frequently utilized in architecture, design, and art. Buildings, artworks, and even products may appear different less aesthetically pleasing to us without it. Third, we have science and math. The Fibonacci sequence is used in many mathematical and scientific models, from population growth prediction to issue solving. Scientists would need to come up with other explanations and understandings of how the universe and nature functions without it. And lastly, we have number 4, our perception to the world. Because these patterns appear so frequently in the things we observe around us, we are compelled to pay attention to them. Without these patterns, we might not see the same patterns in nature and art, and our perception of what is beautiful and agreeable may shift.
In short, without the Fibonacci sequence and the golden ratio, the way the world grows, looks, and works could be different. These patterns influence everything from the shapes of living things in nature to our ideas of beauty in art and architecture, and even how we solve problems.
So next time when you're out in nature, whether you're strolling on the garden or just looking at a flower, remember, math is at work, helping everything grow and thrive.
Math is more than just a number and equation. It is the language that helps us to explain the world around us, from smallest seed to largest galaxy.
And with the Fibonacci sequence and golden ratio, we get to see just how beautifully the nature really is. There's a hidden order behind everything. Thank you for joining us on our little journey through the math of nature.
We hope you saw nature in a whole new light and learned something cool today.
Until next time!
Keep looking for pattern around you.
See you soon, and remember,
Math is all around. Laus Deo Semper.
Bye!
Sophia!
Ayun!
Until next time!
Keep looking for pattern.
One!
Let's see. 2 galaxy.
The cheeks, the Until next time!
Kasi ang pangit.
Hi guys! Nature. Especially in the patterns that shapes the world.
Liam.
Welcome to our vlog!
Comment. Today, we are going to explore the beautiful world. Let's start with the